Third example, 6.2. Tangent squared x plus tangent x minus 2 equals 0. Given the previous example, you probably have an idea about what to do here. Maybe give the video a pause, see if you can figure it out on your own. I'm going to go ahead and work out the solution, okay? So the idea is that we want to try to factor this thing, okay? If you squint at it just right, you can kind of see that this is basically like an x squared, and this is basically like an x. So we have x squared plus x minus 2, right? X squared plus x minus 2. So if I'm trying to factor that, I know that in order to get a tangent squared here, I should have a tangent x and a tangent x. And then in order to get a negative 2, well, in order to have a negative, one of these has to be a plus and one of these has to be a minus. In order for it to be a negative 2, so I need it to multiply to be negative 2 and add up to be positive 1, right? Oh man, it's been a minute since I've factored. We need it to multiply to be negative 2 and add up to be positive 1, so I'm thinking we put a 2 there and a 1 there. That way we get a positive 2 tangent x and a negative 1 tangent x. Those will combine to give us a positive 1 tangent x, right, and a negative 2. Anyway, so there's the factorization. Once it's factored, the rest is history, right? So we can say now tangent x plus 2 should be 0, or tangent x minus 1 should be 0. This means that tangent x is negative 2, or tangent x is positive 1. This one is going to mean that x is tangent inverse of negative 2 plus n pi. This one is going to mean that x is tangent inverse of 1 plus n pi. Okay, now here I think we have to use our calculators because I'm not sure that we have this value memorized. So you're going to have to use your calculator to figure out what tangent inverse of negative 2 is. Let me pull out my calculator. So let's see, tangent inverse of negative 2 is about negative 1.107. This one, though, we know, right, tangent inverse of 1, well, tangent's going to be 1 whenever sine and cosine are the same. That happens when, that happens at 45 degrees, or pi over 4 radians, right? So this is going to be pi over 4 plus n pi. And that does it for that one, right? That's it. So, so that's our solution set, right? All of our solutions would be numbers of the form negative 1.107 plus n pi, and numbers of the form pi over 4 plus n pi, where n is an integer. Okay, if you're looking for the solutions that live between 0 and 2 pi, well then we would start plugging in numbers for n. If I plug in 0, I'm going to get a negative answer. That's too small. If I plug in 1, oh, then I get, 3.14-ish, minus 1.107. So I'm going to say this thing plus pi is approximately 2.034. If I plug in 2, and I'm going to get 2 pi minus some stuff. That'll still be less than 2 pi, right? It'll be inside the interval. So I'm going to say this thing plus 2 pi. That's about 5.176. If I plug in 3 for n, I think I'm too big now, right? 3 pi minus 1.107, that's going to be bigger than 2 pi, okay? But I do the same trick here. If I plug in 0, I get pi over 4. If I plug in 1, I get 3 pi over 4. If I plug in 2, it's too big. Okay? So those are the solutions that live between 0 and 2 pi. Okay, a couple more examples.